So in the last class, we were discussing pandas, and we finished pandas actually. I've also attached the assignment, which was very similar to the NumPy assignment. Some 100 odd exercises, and pandas again, as I said, is a very huge topic. We cannot uh, we cannot spend enough time learning pandas. Even now, after some experience in working with data science, I still find new things to learn in pandas every time. Okay, so it's a never-ending topic. So we have to draw the line somewhere. We have drawn the line where we have covered the basics of pandas, which will allow us to now further explore into our further data analytics skills. Okay. The next package that we look into is matplotlib, and one more called as Seaborn. And these two packages are probably the next in our progression towards data scientist. That as a data scientist, that would be the next logical step to move to. Let me remind you what our journey is, so that we don't lose sight of why we are doing this. Okay. So our ultimate goal is to be able to learn data science skills and to learn the basics that can be applied to data science projects. Okay. Nonetheless, the knowledge of data science skills comes with the idea to be able to implement them on real projects. To be able to implement them on real projects, we use the tool Python for getting this done. So Python is a general purpose language that is not only used for data science, but is used for many other tasks. So in the first few classes, we looked at the basics of Python to know how operators, loops, control structures, functions, data types, modules work within the basics of Python. In the next phase of our journey, we are looking at data science packages that are very useful libraries available in Python that will help us for most of our projects. Okay, so we started with NumPy, then we looked into pandas. NumPy is highly efficient, fast, convenient library that helps us do matrix multiplications and linear algebra stuff that is very useful for implementing machine learning programs. Okay. The other thing we looked at is we looked at pandas, and pandas is very useful for doing for the entire process actually, from reading the data to transforming it, cleaning it, dealing with missing values, doing descriptive analytics, doing some basic visualization, doing transformation, doing feature engineering, and so on. Okay? So there are many uses of pandas, and we looked at that till the previous few classes, and now we are shifting gears towards doing visualization. So a big job in a data scientist role is to be able to take raw data and to be able to visualize it in different formats. Okay? And for that, we will be seeing two tools. The first tool we look at is matplotlib, which is the entry point towards visualization. And the next tool we look at is Seaborn, which is very quickly and very soon it is gaining momentum as being one of the interesting packages that data scientists use for getting visualization done easily. Okay, so in this class we'll look at matplotlib. Like, before we start, do you have any questions? No, great. Okay, so let me run through matplotlib. This is a fairly simple class, and we should be finishing it very soon. Okay. So here, matplotlib is our visualization package, and we will use it for doing multiple things. First thing we look at is at drawing very simple line plots. Okay. So the way we call matplotlib is we call it using the command import matplotlib.pyplot as plt. So this will invoke from matplotlib the pyplot package, which we loaded as plt. You can load it as any name, but plt is the standard name that most data scientists use. So if you use plt, your code will be very readable. The first line here, percentage matplotlib inline, is a line we add so that our plots are available within the Jupyter. Okay, since most of our initial learning will be on Jupyter notebooks, it makes sense to do this. We are writing this command plt.style.use seaborn white grid. So this is a command that uh, gives us default styles. Okay, so just like themes or templates that we use, this template is the default, or is a, it sets up that for all the plots that I will use within this notebook, unless you change it, the default style will be seaborn white, and we'll see what this means. Okay, or this basically decides what will be the color of my grid, what will be the size of my text, and so on. And of course, we can modify them or override these parts, but the default will be set by this template. Further, we call numpy to create some data that we can plot. Okay. Now, for all plots, we start with a figure and an axis object. Okay. So let me first execute the first line. Okay. A figure and an axis is something that we will use to plot. Figure is the image that is created, that is being shown here. This image can have multiple arguments or multiple things that we can control, like the size and so on. And then we have the axis object, and the axis object is the actual axis that we'll be plotting on. Okay, so we would be familiar with what the grid is, what the x-axis, y-axis, and so on. So those properties are available with the AX object. Okay, generally we start with these two things. And maybe we can take an example that makes things clear. So let us create some data. So we are creating the x-axis, that is the independent axis, and we're creating the independent axis using numpy package by calling a function called as linspace. Okay, np.linspace. And if you've worked with MATLAB, this command would not be very unfamiliar. In fact, there's a very familiar command which says that I want to create a linear space which starts from 0, ends at 100 with steps of 100. Sorry, starts at 0, ends at 10 with 100 points in between. Okay, so this will create my x-axis from 0 to 10 with 100 odd points in between. Okay, 100 equidistant points in between. We could have done that another way. We could have written the range command and writing 0, comma, maybe 10 by 99 colon 100. So basically, let me quickly show you what I mean. When I write this command with x, it says, okay, these are the numbers that we are using. We could have also created that using x is equal to np.arange. It says start at 0, end at 10, take steps of 10 by 99. Okay, and I write x, and that gives me the exact same values. Okay, so just a way of creating the x-axis. And once we have the x-axis, we are saying we will plot it. Okay, to plot it, we are saying plot it in the axis object ax with the command .plot, and on the x-axis use the x variable as points. For the y-axis use np.sign of x. Okay, so take sign of that quantity, and that is what we'll plot on the y-axis, and we get this neat plot. This is a standard sine curve. We are not defining frequency, so the frequency would be 1 pi. That means within 2 pi, within 2 pi units you will finish one cycle. So that is here 6.28, we finished one cycle, and so on. So we're just using this as some demonstration data to use. Yes, Anand, you're saying something?
Yes. Why you are using AX dot? It should be FIG dot plot, right? We are plotting in a figure. Why we plotting in an axis?
Yeah, we are actually plotting in the axis, and that axis is in the figure. Does that make sense?
Not really.
So consider the figure object as a superset, and
Okay.
within that figure there is an axis object, and we are actually plotting on the axis object. The axis object is the one that gives you these grid lines and the xy space.
So how this AX is dependent on FIG? I didn't see any. Okay.
Yeah, since both of them are called from
And the
the,
plot. Okay.
yeah,
Yeah.
yeah, both of them
Okay.
are called from the PLT. That the side. So each cell defines this figure and axis. So in the next part, when you use AX, it would not be the same axis. You would have to probably define it again.
Okay. Fine.
Okay, so for each plot, we write this command. This is actually a long cut. We will look at a shortcut, uh, and I will explain what is the difference between the two. Okay.
Yeah, fine.
So here in this case, we are able to see a sine wave, and so we see even in the background, matplotlib has done a lot of things. Okay, first it has assigned your x ticks, and it is giving your x ticks. It has assigned your y ticks. It is giving your y ticks. It has assigned your grid and has divided into some division that may or may not be useful, but it provides us with some input. Okay, now this idea of getting uh, uh, the grid lines and the ticks and all, they come from the line that we used here. Okay, PLT style use Seaborn wide grid. If I try to remove this line and maybe reset my controller, we would see a different kind of plot. Okay, so now I've reset the controller, so I've reset everything again. I start creating the plot again, and you see now this plot looks a bit different. There are no grid lines. There is a dark black border, and the text is black. Okay, so this is probably not a very interesting figure to look at because it's not that neat. Okay, so visualization generally we want neat stuff, and we'll see by taking help of Seaborn package we can do something more interesting. For now, I'll go back to Seaborn because I like those plots, and when we explain Seaborn, I explain why I talked about this part as well. Okay. So to get the same thing done, there is a shortcut. We can use plt.plot with x and y. And what this command will do is in the background, it will create the figure, it will create the axis, and it will plot on that axis. Okay. So even though you do not have access to the figure and axis variables, it still is doing that in the background. Okay. Now, the advantage of this method is it is a quick method to see your plots. And in many cases for getting quick visualization, we use this method. When we want more control over individual axes and figures, want to create subfigures, subplots and stuff like that, we go for this method because this gives us more control. We can do many things with both these methods, but more control is available within this longer method and lesser control, quicker answers are available with the shortcut method. Let's go ahead in our journey. Let's create two plots. So to create two plots, we are just writing both of them in the same cell. Here I'm taking the same x data and np.sinx that gives me the blue curve, and x np.cosx gives us the second curve. So we see that matplotlib has understood that there are two curves, and since they are in the same cell, the two curves need to be plotted in the same axis. It has also understood that there are two curves, and it has assigned default colors to the two curves. And with more control, we can of course adjust the color and sizes and line styles of these curves. Okay, let me go ahead. So this is another example where we see how we can assign colors to the different objects. So for the data, I'm just taking the same x and np.sinx to plot, but we are starting at different offset values. Okay, so x minus 0 with this offset we get this blue line, x minus 1 with this offset we get this dark green line, and so on. Okay, so uh, yeah, so I'll explain how these colors are chosen. Okay, so matplotlib allows us to choose colors in multiple and different formats. Okay, so here we have shown 1 2 3 4 5 6 of these formats. The first format is we define the color using the name of the color. Okay, so there are many colors, when at least many basic colors whose name that we understand. We can just write the name and matplotlib decides what the color looks like. Okay, and it just plots it with that color. Then we could use short color codes to define the names. Okay, this color codes comes from this group RGBCMYK, which stands for red, green, blue, cyan, magenta, yellow, and black. Okay, K for black. So these are short codes that we could use, and providing that as a single string, single character string, we can get the different colors. So here we are using G, which stands for green. That is why we get this dark green color. The other thing is we can provide a number between 0 and 1, and this number between 0 and 1 would represent grayscale numbers. Okay, so if I put 0, it gives me full black, and if I take it towards 1, so let me put maybe 0.8, you can see a very light grayish line. Okay, 1 would make it fully white. Okay, you see it's not even visible with the background here. Let me shift back to 0.5, which is somewhere in between. So it's a grayscale number, which you're able to control the color intensity from white to black using the numbers 0 to 1. The next is writing the hex code for getting the plot, and hex code is a hexadecimal number that represents the color. So here the hash says that what it will follow will be a hex code, following by 6 characters. The first 2 characters, so each characters comes from a group, goes from 0 to FF hexadecimal, and the first 2 represents the component of R, the next 2 represents the component of G, green, the next 2 represent the component of B, blue. So red, green and blue. This is the RGB is the standard notation that we use to define colors. So it takes a huge range of values. Okay, so here we are saying FF means use 100% red component. Then we say DD. So DD is somewhere in between from 0 to FF. Use that much component of green, and 44 is lesser component of blue. So when we take all these 3 colors and we add them together, we get this yellowish looking color. Okay, so when we take green and blue and red in this format, we get this yellowish color, and that is what we are seeing here. Okay, so after this grayscale, we have seen this yellowish color. Let me show you by changing some numbers to see if this changes. If I say F0 and execute this, let me, yeah, it is difficult to say like this. So probably let me remove all the red component and remove all the green component and maximize the blue component. We should see that this yellow line would look bluish. Okay, so this has become dark blue, and then here by reducing the numbers, we can change the component of blue and so on. So let me go back to the old numbers. That gives us a yellow curve. Following that, we can define colors in a tuple format. So in this tuple format, each number takes values from 0 to 1. There are 3 numbers representing the red component, green component, and blue component. The same like before, but instead of the hexadecimal code, we are giving a number between 0 to 1, and that defines our color. So in this case, we have more reddish, less green, less blue. So our curve here looks more reddish in nature. Okay. And then finally, we can define all HTML color names. So if you are familiar with HTML or CSS, and you've got certain names, color names that we can use, you can use those color names as well to define colors. Basically, we see that matplotlib is very versatile. It does not stick on one idea, and you could choose any color scheme that you want. Okay. Just 1 second. Okay. Further than that, we can choose the different line styles and see how we can plot different line styles. Okay, so we have taken a simple curve x and x plus 0, 1, 2, and so on, which will give us your 45-degree slope with different offset values, and that is why we are getting these different plots. For these different plots, we are applying different line style to see how we can get the different line styles. Okay, so a solid line style gives this straight line. Dashed line style gives us with this hyphens, separated hyphens, that is a dotted line. We call it a dashed line, sorry, because we have another dotted line here. Then we have dash dot, which as it says, puts a dash dot, and so on. Dotted puts these dotted lines. So we can control these 4 kinds of line styles with our line style command. A shortcut to these line styles would be something like this. A single hyphen would mean what do you say, a solid line. Two hyphens would mean a dashed line. A dash and a hyphen and a dot period would mean a dash dot line, and then a colon represents dotted line. Okay, so these are just shortcuts for getting different line styles. We can also combine the two, that is color and line style, to get what the combination that we want. So hyphen green would mean solid green. Two hyphens and C would mean dashed cyan, that is getting this cyan. A dash, a dot, and K means dash dot black, that is what we have here. And then colon red would mean dotted red. Okay. Let's go ahead. We can also control the axis limits. So once we plot x and sin x, we get this graph, and I can control using the x limit command. plt.xlim controls from where does my x axis starts till where it ends. So here we are saying start from -1. So this is 0. This would be somewhere -1 and end at 11. So that is how we have controlled the x axis. Similarly, the y limit we can control from -1.5 to 1.5. So this gives us the we can control the axis. So let's say maybe we can experiment. If I just want the positive part of the first cycle, then I would say my x limit would start from 0. It will go to 3.14. My y limit will start from 0 and it will go till 1. Okay, so this would be exact cut to cut of our curve, and we see that we are even crossing some borders. Okay, so we would want to give some some relaxation to this. So I'll start from maybe -0.5 to 3.5, and here maybe -0.5 to 1. Maybe -1.1 to 1.1. Okay, and that would be our top curve. So our x limit, we can zoom, using x limit, we can zoom on different parts of our curve by choosing what values we want to use for our axis coordinates. Okay. We can also do very interesting things. You can flip a curve as well. So the way we can flip a curve is we define the x limit to start from a bigger value and end at a smaller value. So here you see the x-axis, it starts from 10 and ends at 0. And a y limit also we have flipped. We are saying it starts from 1.2 to -1.2. So this curve that we had drawn is now flipped both in the horizontal axis and the vertical axis to be able to get this curve. Okay, so you see, you would actually read something like this. Your curve will start here and go backwards doing this. So by using x limit and y limit, we are also controlling how our plot axis looks like. Then we have, along with x limit, y limit, there is a standard command called as plt.axis, and this allows me to control all the four things: x limit, y limit, x minimum, y minimum, and y max, using one single line. So I take the axis command and provided a list of numbers, and the list of numbers represents this. Okay, the first number represents the x minimum value, so we start from -1. Second number, x max, end at 11. Then y minimum, which is 1.5, -1.5 to 1.5, y max. Okay, using one command we can also control all the different axis elements. Now, if we don't want to give this, if we want to use words, so matplotlib has certain default values. So when you say tight, what it does is it automatically tightens the axis limits so that the entire boundary is covered. Okay, so our entire signal should be covered inside, and it gives us a tight boundary. That is one option. We can use axis equal, which says that the same units that we have on the x-axis should be on the y-axis as well. So what does that mean? So if 0 to 2 takes this much space on the x-axis, 0 to 2 should take the equivalent space in the y-axis as well. So in all these graphs earlier, we have seen that our y-axis is actually zoomed in than our x-axis. So here y-axis goes from -1.5 to 1.5, which is only 3 units. That is, here to here would be 3 units. So here to here is taking much less space compared to this, okay? So we know this is an uneven distribution of axes, and it is useful sometimes, or sometimes we may want equal distribution. That is why we can use axis equal, and that gives us this equal kind of graph, okay? Further, we can label the different plots. So many of the times, just the plot is not enough. We need to add some help that can help the user to read the graph well. So we can give a title to the graph using plt.title. So here we are saying a sine curve. That is how we get this part. We can use the X label. On the X label, we say we can write some text here. So here we are just writing X. Y label, plt.y label gives us the Y label here. Okay. Let me go ahead. So the notebook is self-explanatory actually. So later on, if you just read through the notebook, you will get a lot of content. I'm just going through quickly. Okay. Here we can do some more things. We can label the graph. So especially when there are multiple curves, so like say our example earlier, when there are multiple curves, it becomes difficult. What curve is representing what value? Okay. So to do that, we use something called as legends. And the legend is we will assign a certain type to a certain curve, and then we'll put a legend like this. We'll put a help like this that tells us what curve represents what. Okay. So in this case, we are plotting two curves by plt. The first is np.sinx. We are plotting that in a solid green, and we are giving the label as sin x. This is the label that gets that gets printed on this on this legend here. Then we are plotting a cos x with dotted blue. That is what we give, and then we are giving the label cos x. We are saying the axis to be tight. That is, it will be a tight boundary around all the over the entire signal. Okay, and we use the command plt.legend. When we use plt.legend, matplotlib takes these labels and takes an example of these tiles and puts it something like this. Okay, so it puts that we have a solid green sin x and a dotted cos x. Now we saw all of these commands using shortcuts of plt. If you want to do this in the long cut way, that is by using axes, these would be the corresponding commands. plt.xlabel would become ax for the axis object dot set underscore xlabel. plt.ylabel would become set underscore ylabel. Xlimit will be set xlimit, ylimit will be set ylimit, title would be set title. So in most cases, we just put set and underscore, and we should be done with that. Okay, so let's look at an example here. So we are using plt.axis to create an axis object. So here in the background, it makes the figure object, and we are not seeing the figure object at this point. We're not seeing means it exists in the background, but we do not have the handle to it. So if you want to have the handle to it, we cannot do it here. Okay. Let's see ahead. We're using the ax.plot to plot the to plot the curve with the x coordinate and the y coordinates, and we use ax.set to set a multiple values. Okay, so we are setting the x limit to 0 to 10. We are setting the y limit from -2 to 2. Within the same, we are setting the x label as x, y label as sin x, and title as a simple plot. So just by writing this one function call, we are adjusting all the different parameters for this plot. Okay, and sometimes this is useful, is especially when you want to create a lot of plots. You can save all of these configurations in a dictionary, and you can call that dictionary multiple times to get all of these plots here. And let's say when you want to change them, you update your dictionary once, and all of these plots get updated. So that is the advantage of using the ax object. Okay, though it looks harder at times, that is, though it looks maybe more comprehensive at times, we can see that it is very useful when we want to create a lot of plots. Let us go ahead and see what. So these were the line plots, and plus we also got exposure to how PLT or how matplotlib plots. What are the basic commands? Let us now go towards more different kinds of plots. We're looking at scatter plots now. Scatter plots are plots where your individual points are shown as dots or some markers. They are not connected with lines generally. Okay. So there are multiple ways of creating scatter plots. Within matplotlib, you can create a scatter plot using the plot command that we have seen earlier, and just by changing the marker. So this is the same plot command like we have used so far. Okay, but here we never give the marker. When you don't give the marker, matplotlib assumes that you want to connect the lines. So there are 100 points, so it just connects the lines and then gives us a neat curve. When you don't want to connect the lines, we say that we want a marker. So you give a marker like this. So here I'm saying the marker is an O, and O represents these dots here. And this is the marker that is being used to plot these lines. Okay, so we have the same data, x-axis, y-axis, and we're just using 30 points now. Okay, from 0 to 10, 30 points. And these 30 points are shown here. We're saying plot them with an O and color it black. Okay, so let me probably increase some points to probably show what is happening. So if we take 50 points, we see that the points are now closer together. 100 points would mean something like this. So even when we were doing earlier, when we had 100 points, we had these points, but matplotlib had connected them using using a line. That is why we were not able to see the difference between them. But if we go to lesser number of points, we can see what truly is happening in the background. Okay. Yeah. So let us see what other markers are there. So here in this case, for making this plot, we are randomly generating some data, and we are randomly assigning some or we are assigning some markers in a line to see what are the different markers we get here. Okay. So first I am setting the random state to 0. That is, every time if I don't put this line, let's say I comment this line and I run this plot, every time I should see, oh, okay, let me not do this. Probably I'll explain this later on. Okay, so by basically setting the random state, we are telling that every time we want to read from, we want to get an output of the same randomness. Okay, so if I put maybe the seed 10, then I'll get a different state. But whenever as many times as I run this, I will keep on getting similar plots. Okay, so let me go back to random state 0. This is the plot that we get. For this plot, we are saying for PLT figure, make a figure object. Again, this is getting access to the figure object in the background. Make a figure object with 10 units on the x-axis and 5 units on the y-axis. Okay, so that is what we get here: double on the x-axis and 1 unit on the y-axis. And we will change our markers to take all of these values. Okay, we want to see what marker, what plot do we get with O, with dot, with comma, x plus v, hat, left, what do you say, less than sign, greater than sign, s and d. So we'll use all of these markers and we'll see what kind of plots we get. For each of these markers, we are randomly taking 5 points on the x-axis, 5 points on the y-axis, using the marker that we chose here as the marker that we'll be using for our plot, and we are assigning a label here. So for this label, we are assigning the string, and the string says that you should print the label as marker is equal to the first element provided here. So the first element provided here is the marker that we've given here. Okay, that gives us this plot. So let's say it takes the first value O, and for O it creates 5 points on the x-axis. So you see 1, 2, 3, 4, 5, and this O we see is plotted in blue. So when you don't provide the color, matplotlib automatically takes colors from a set and it provides them in that order. So giving an O gives a marker like this, giving a dot gives this marker like orange. You see these orange small dots. Giving a comma gives us very small points in blue. You see 1, 2, 3, 4, and 5. Yeah, I think 4 is here. Okay. Giving an x gives us these x. Plus gives plus. V gives this lower or downwards pointing triangle. Hat gives us upward pointing triangle. Left and right or less than and greater than signs gives us these kind of triangles. S gives us a square, and D gives us a diamond. So these are the different markers that we can use. There are other markers also, but for most cases, these should be a good set to start for. Okay. We put the legend as 1, so we get this point here, and we assign the x-axis limit to go from 0 to 1.8. Okay. So this is how our scatter plot would look like. Let's go ahead. We are joining a scatter plot with a line now. So hyphen saying that I want a solid line. O saying that these will be the markers that we'll be using. And K tells us the color they will be in. So we get a black dotted line with markers. Now in the plt command, we can control a lot about this. Okay. So here we are starting with saying that use a dashed P. Okay. So dash says tells you solid line, and P tells us that we want a pentagon. Okay. So you see all of these markers are in the shape of a pentagon. Okay. We can choose multiple parameters here. So this color defines what will be the color of the solid line. So I've given red, so this shows red. Let me change it to maybe blue. So I'm using the shortcode B, and that makes this solid line of blue color. Then we can control marker size. That is, you see the size of these pentagons. We have given 15. So make it 5 and I run this. We see much smaller pentagons. In fact, they are not even visible. To make it bigger, maybe let's say 20. We'll see these big size pentagons. Okay, so depending upon your marker size, we can control the size of the marker. Let me go back to 15 probably. By controlling line width, we can control what is the width of this solid blue line. Okay, so 5 gives me this, 3 would be a smaller line, and then again 10 would be a bar kind of stuff. Okay, so a 10 would be a very thick line. Let's stick to 5. We can control the marker face color. So the color inside the marker we can control using this. So here we have given yellow. Let me take magenta. This is what magenta looks like. Let's probably stick back to yellow. Yellow looks better. Okay. Then we can choose the marker edge color. So you see the edge of the marker that is in blue. I change it to a red. You can see now the edge of the marker is red. And marker edge width. So we can control that width also. 1. This 2 is a bit thicker and so on. So we can see now with so many commands, so many arguments, we have access to changing many of the quantities of many of the parameters of how the plot is visualized. Okay, and in our journey as a data scientist, we'll see that visualization is a very important tool, and it is important that we can control many of these aspects using code. Okay. So this was, we have seen scatter plots using the plot command and using marker. But let's go ahead and see that within matplotlib, we have a plot called as plt.scatter. And that scatter gives us more control over the scatter plots. An example of that is I'm using the same data. And with the scatter plot, I'm using a marker. And you would say that this plot is exactly similar to what we have seen earlier. What is the advantage using the scatter plot rather than the normal plt.plot? And the advantage comes here that with scatter plots, we can control individually the color of each of these dots. Okay, color and different sizes. So here, when we for plt dot plot, when we are using this scatter plot, then whenever we change any of the parameters, this parameter affects each of the points. Okay, whereas using the plt.scatter command, we can control separately each of these points. So let me show an example of what I mean. So here we are creating 10 random x points, 10 random y points, and we are generating the color randomly in a range of 10. Okay, so we are estimating the color randomly, and I'll tell you what this means. And then we are saying that the size also of each of these blocks are coming from a random number. Okay, so 10 random x points, 10 random y points, 10 different colors, and 10 different sizes, okay, of the plots. So we're just multiplying by 100, multiplying by 1000 to scale the sizes to bigger numbers. Okay. Then when we use the plt.scatter command, we say these are the x point, these are the y points. C is equal to, these are the colors we are providing. So this is, if you remember our function and arguments, this becomes our, what do you say, a keyword argument that we are providing for colors. S is equal to sizes are the different sizes that we'll be providing. Alpha is equal to 0.5. Does anyone know what alpha 0.5 stands for? Okay, so alpha is a very generic term for many plotting environments. Alpha stands for what is the transparency level. Okay, so closer, let me check. If we put 0, that means fully transparent. When we put 1, it means fully solid. Okay, and any number in between would represent how much transparency we want. Okay, so this is very useful, especially when we may have data that is overlapping one over the other. Okay, and CMAP is the color map. That is when we are fetching colors. Uh, what is the palette we are fetching colors from? Plasma palette looks like this. It starts from this violetish color to yellow, and then it changes, or it follows a gradient to follow this color. So when we run this command, uh, it gives us this plot. When we run this command, it gives us the color bar. So here we can see there are different blocks with different sizes, and uh, they're representing now using this one plot. Can you tell me how many dimensions we are showing? What is the dimension of this plot?
2 dimensions.
Mhm. Okay, that's a good answer. Uh, but we are showing more within this plot. Can anyone suggest what else are we showing in this plot? Okay, so this is a 4-dimension plot, and why we are saying it's 4 dimension is we know the normal 2 dimensions x and y. So each point has an x coordinate and a y coordinate, but we have added color. Okay, by changing the color, we are adding a 3rd dimension to the plot, showing what the color is, and a 4th dimension by adding size to the plot. Okay. So each of our data points are representing 4 quantities here. So here this quantity tells me that I have an x-axis of somewhere like minus 0.1, a y-axis of maybe minus 0.1 here again. That is my x and y values. Then the color here shows me that I'm somewhere between here. So this is maybe 0.6 to 0.63 or 0.65, and the size tells me some other figure. So this size tells me that this is lesser than all of these values here. Okay.
Then in that sense, it's a 5 dimension, right? Then transparency also will be one more dimension.
Uh, hmm. But no, transparency will not be a dimension because the transparency parameter affects everything at one go, right? So if I had the option of setting different transparency levels for each of the dots, then we would call it 5 dimension. Okay, but since that is a common thing, right? The
Yeah,
transparency
yeah.
parameter affects all of them. It's not truly a dimension. This. So why this is important? This is important because especially in data science, we deal with very high dimensional data. Okay, uh, very high dimensional data means the data has multiple features, and for these multiple features, uh, uh, we are trying to design algorithms and we are trying to do things, and it is very difficult to see those multiple features in one plot. Okay, so if we are limited only to our 2 dimension or 3 dimension plots, that is all we can do, but adding color and size gives us these extra things that we can play with. Okay, and I'll show you an example of why this is important. Okay, so here I'm taking example of the iris dataset. So let me, yeah, let us probably see this one, and then I'll go back why I have shown this one. And in fact, I can, yeah, let me delete this altogether, and we'll start from here, and then we'll see what this means. Uh, I'll split the plots. Okay. So yeah, from our scikit-learn package. So this package is something that we'll look later on for our data, for our machine learning task. But right now I'm just using this package to load a certain data set. Okay. So from scikit-learn.datasets, I'm importing a data set called as iris dataset. So I'm calling the load iris function. And here I call this function load iris to create this iris. So let me show you what this iris contains of. So if I just write iris and press enter, it gives me, can you tell me what data type it is printing here?
Dictionary.
Yes, it's a dictionary. We can know that by looking at this curly brace. Then we see that there is a keyword followed by a colon and then values. Okay, so this is a dictionary in which I have keywords like data, and data has a big set of values. Let me scroll all of this. Then I have a keyword called as target, frame, target names, this DSCR. So this stands for description. And we see that, we can see that's a huge description. And when you see this /n, that represents a new line. That means this description is a printable description. And let me go ahead. So these are the different things here. Probably if I want to know more, I can print the description and I will get more idea about what this is. So I'll write print iris DSCR, and that gives me this neat formatted text. Okay, so if I quickly read what this text is showing, this text, the iris is your iris plants dataset, and the characteristics of these datasets are there are 150 instances of 50 in each three classes. So there are three classes with 150 instances. So 50 for one class, 50 for class 2, 50 for class 3. There are four attributes or four features. All four features are numeric, and they are predictive attributes of the class. Okay, predictive attributes means these attributes help us to classify the three classes. The four attributes are sepal length, sepal width, petal length, and petal width. And the three classes are iris setosa, iris versicolor, and iris virginica. So these are three species of a same flower class called as iris. Iris is a flower class, and setosa, versicolor, and virginica represent three species of this flower. For each of the flowers here, we have measured, we have means this person here, Sir R.A. Fisher, has measured four quantities about each of these flowers. Okay, sepal length, sepal width. This is the outer petal length and width of the flower of each sepal, and then the petal length and petal width. Okay, so for 50 flowers of iris setosa, he has calculated or he has measured these values. For 50 flowers of iris versicolor, he has measured these values. And for 50 flowers of iris virginica, he has measured these values. Okay, and he has given us access to these values in the data table. So we saw that this iris thing had a key called as data. So I put that and I press enter. You see these numbers. Okay, so we, for each row I have four numbers. The four numbers represent sepal length, sepal width, petal length, and petal width. Okay, sepal length, sepal width, petal length, and petal width. And then let me go create another cell, and I put iris, and there was another this called as target. The target represents the class. So the first 50 is class 0, and class 0 represents, let me go back, iris, target names. Okay, class 0 represents iris setosa. Okay, so we have 50 examples of iris setosa, followed by 50 examples of iris versicolor, followed by 50 examples of iris virginica. Okay, so this is what the data is, and this is a fairly interesting data set that shows how the simple task of measuring the information on these four parameters can help us classify the three different flowers. So in the future, if we know we are coming from this data set, and someone gives me for iris versicolor, gives me the four numbers, I will be able to look at these numbers and tell that which flower are you talking about. Okay, so this is a machine learning problem, and for our case, we are not entering into machine learning at this point, but we are using this data to see the different plots. Okay, and we want to see how visualization plays a role in these plotting. So I load the iris dataset here, and I'm saying the features of the iris dataset is taken from here. So I'm taking the iris data and doing a transpose on this data and loading that into a variable called as features. And these features is what we are using for plotting this plot. Okay, so when we do plt.scatter, can you tell me what is the first parameter we pass to scatter?
That is x-axis, right?
Yes. So first parameter is what we want to show on the x-axis. Second parameter is what we want to show on the y-axis. So there are 4 features here. Okay. So out of these 4 features, feature 0 we are putting on the x-axis. So feature 0 was, let me show you. Okay. So if we take iris, we put feature names. Feature 0 is sepal length. Okay. So we are putting sepal length on the x-axis. We are putting sepal width, features 1, on the y-axis. We are using an alpha of 0.2. So alpha of 0.2 means transparency of 0.2. Then S controls our sizes. So we are taking feature 3, which is our petal length, and petal length shows what will be the size of the petals. Okay, and we are multiplying with 100, and that controls our size parameter. And we are using C, the class. Okay, the color C is decided by our iris target. So our target is the 5th dimension, right? It tells us which of the 3 classes we are using. So our target is what we are choosing to define color C, and CMAP, that is where is this color being taken from. This color is being taken from the CMAP palette. CMAP palette would be a palette, maybe we can, I don't know if this will work out, but let us do plt dot color bar. So this is the CMAP, the Viridis palette. We see it ranges from bright yellow to light bluish or violetish color. Okay. On the X label, we are putting feature name, Y label, we are putting feature name, and we get this plot. Okay. So if you look at this raw data, I have removed it. Let me go back and write features. If you look at this raw data, this data hardly makes any sense. Okay, I cannot look at this data and remove patterns or see what it is trying to show. But when I look at this plot tells me a lot more information. It tells me that if I draw a line here, probably this line less than this line would mean I'm using either of the two uh, classes, and greater than this line represents I'm talking about one special class. Okay, so we see that this line, by drawing this plot like this, I can see that if I draw a line, I'm able to classify between I'll be able to classify between at least one of these plot groups. Looking at this plot, I can also see that it will be difficult for me to classify between this blue and yellow groups. Okay, because they are so mixed together. Okay, let me change the, yeah, so this will give us more idea. So I've reduced the transparency a little bit. I can see that these blue and yellow yellow dots are more closer to each other. Okay, and it would be probably, at least in this view, it would be difficult for me to separate the two. uh, so this is where a scatter plot is useful. We are able to show multiple dimensions in one plot. Okay, is this clear so far? Okay, great. So I would love to say one quote here, since we are talking about higher dimensions. The quote says like this. Okay, if as humans we had the ability to visualize in higher dimensions, then we would not require machine learning. Okay, so I'll repeat that again. If as humans we had the ability to visualize in higher dimensions, then we would not require machine learning algorithms. So we require machine learning algorithms because as humans we fail, or it becomes difficult for us to visualize higher dimension quantities. Okay? And thus we cannot see those patterns. So here in this case for us, when you look at this blue and yellow, they seem to overlap, right? But if you imagine there is another dimension, so there is one dimension that we are not plotting here, right? We are not plotting features 4. So let's say if I'm dividing this between feature, okay, we're not plotting feature 2. If we do 0 and 2, and if I run this plot, I can see a different view of this graph. Okay. You see, in the other view, we are looking from a different angle, and we can see this blue and yellow, they are so overlapped with each other. But when I change the axis and I add this another dimension, I can see that probably in one of these dimensions, there can be a plane that could separate the blue and yellow from each other. Okay. And in this view, it is very difficult to see that. In this view, it is very difficult to see that. But if I change my view a little bit, I'm able to see that probably I can draw a plane, a two-dimensional plane that would be able to separate the blue and yellow as well. And these are the kind of things that we want our machine learning algorithm to pick out and use for classification. Okay, we are not talking classification here. That is a topic of the future. But I still wanted to say this point since we are, plotting this in higher dimensions. Okay, so let me go ahead. So how do you choose between plot and scatter? So if you want something like this, that is, we want different plots with different sizes, we use scatter. But scatter will take longer time to plot, especially when I have huge data set. Okay, so generally this data set is fairly small. We just have 150 points. But for machine learning tasks, we generally have we have huge data sets, somewhere ranging from thousands to millions, depending upon our application. And doing a scatter plot can take a huge amount of time. So a suggestion is, if our dots look similar and we don't want the difference of adding multiple dimensions, we can use the plt.plot command, and that would be much faster compared to the plt.scatter command. Okay, but again, it depends on our need. Let's look at another kind of plot. We look at histogram spinning intensity. I'll quickly finish this point and we will end this lecture. So here we are taking a random data set. I'm creating np.random.random, and we are taking 1,000 points. That is from a normalized random set. We are picking out 1,000 points, and when we do its histogram, so when you say plt.histogram, we get this plot. I think we have seen histogram in our example for pandas also. I don't recall fully, but plt.histogram would give us this histogram, which says histogram is a graph that shows frequency. Okay, so this says that most of our data is belonging to has a mean of 0, that is, they're closer to 0, and as we move towards the end, we get lesser and lesser data. Okay, so by default, this is what matplotlib prints for us. This is what matplotlib prints for us. But in this graph, we can control a lot of things. We can choose to control bins, and bins are how many of these bars, how many of these groups we want. So if I say 30 bins, then I have a much granular bins, and it gives me more number of steps. We can choose alpha, that is, we can choose transparency level, and this is especially important when I'm drawing multiple histograms in one plot. Then I will be able to see where they are, how things are happening. We'll look at an example of that. We see the histogram type. So this is step filled. We can choose the color. So we're choosing the color steel blue, and our edge color is also we can choose. So we are choosing gray. Let me show you red to show what I mean. So we can choose the edge color as well. Okay, this would be one way of doing a histogram. But when we want to plot multiple distributions in one place, we can use something like this. So I'm creating 3 different data sets, and these 3 different data sets, for the first x1, I have a mean of 0 and a standard deviation of 1, and there are 1,000 points. For the second data set x2, mean of -2, standard deviation of 1, and 1,000 data points. x3, mean 3, standard deviation of 2, and 1,000 data points. Okay, for these 3 data points, we want to plot 3 histograms, And since I want all the quantities of my histograms to be similar, I am creating a dictionary out of this. Okay. And for this dictionary, we have defined quantities here. So like this, histogram type should be step filled, alpha should be 0.3, density should be true, and bins should be 30. So this is our dictionary, which has defined all these parameters. We call it as keyword args, KW args, and we pass this as input to our histogram function. That way, by just changing the dictionary here, we can control all of these plots. Okay. Sometimes if I decide, no, I don't want 30 bins, I want only 20 bins. When we run this, it gives me 20 bins. Or let's say I want 50 bins, it runs 50 bins and gets me this. Especially when you're dealing with multiple plots, this kind of approach is useful because changing one number can affect all the plots that we're using. Okay. We provide 3 labels, x1, x2, and x3. And we can see these 3 plots. If alpha was 0, if alpha was 1, it would be difficult to see for this blue curve how it is being distributed. Okay, so giving an alpha value of maybe a smaller value, then we can see what is happening in the background. Okay, now if you look at this graph, we can quickly visualize that for this blue curve, my mean is 0, that is, it is centered around 0, and it has a standard deviation of 1. That is, most of my data is, or 90% of my data is comprised within a distance of 1 from the 0 point. If you look at the second curve, x2, we can see we have a mean of -2, and again a standard deviation of 1. For the third graph, we can see a mean of 3. So you see most of the data is centered around somewhere between 2.5 and 3. That is our mean. And our standard deviation is 2. So this is a much larger scope in how the data is distributed. And since all of them have only 1000 points, these two are probably the similar height. But since the green one is distributed over a bigger area, the height becomes smaller. Okay. Yeah, then, so that's it. That's our histogram. We can do something more. If I say np.histogram and give data, we can divide how the data is distributed. So I can get the different counts and bin edges. Counts tells me that in each bin, so here for this data, this is a different example. Okay, this has nothing to do with this case. We're just creating some, we're looking some data that we had created earlier. Let me see. For this plot, we are looking at how many elements are there in each bin and what are the bin edges. So we can see 23 elements in the first bin, 230 elements in the second bin, 490, 459 in the third bin, and so on. This gives me the count of how many elements are there in each bin. And this gives me the bin edges. That is, where does the bin start, where does it end? Probably this is not so important. I may just move it. So far, this is what we have seen with matplotlib. We have seen that we can do line plots, we can control the different lines, we can do scatter plots, we can control the different sizes, colors, and so on. We can also do histograms. We can do some more plots, we can do box plots, and we can do bar charts. And we'll look at when probably in Seaborn we'll see some of these examples. Is this clear? Okay, great. Of course, we have not covered everything in matplotlib. Matplotlib again is a big library. It contains lots of visualizations. We're just looking at the basic ones. And when we actually come to our examples, we'll see some more examples coming in that we use. Okay. This part does not have any assignments. This is fairly simple, but you can go through the notebook and you can try modifying some things here and there to see how you can control the different plots. Okay. If you have any questions, we can take those, or we'll stop for now and then we'll continue. So now we can continue again on Monday. Okay, so Monday at 7 a.m. IST. Okay, then bye-bye.
Okay, bye.
Bye. Anand, if you have some time, we can wait some 5 minutes.
Yeah. Sure.
Stop sharing.